In this video, I'm going to run through how to add fully modeled threads to the nut we created in a previous video using the integrated hole tool that has recently been added to Alibre Atom 3D version 28. So for this, I'm just going to go open, and I'm going to open the existing hex nut model that we started with previously. And that brings us into the part workspace. So I need to remove the chamfer and hole we initially created in order to then be able to add it back in with a thread using the hole tool. So to do this, I'm just going to go onto the tree, right click and delete the chamfer. And then under the extrusion, we actually included the hole as part of the base extrusion. So I'm just going to right click and edit to go back into the sketch. And then I'm just going to select the inner profile for the hole and press delete. Then tick deactivate sketch top left to come back to the part workspace, and now we've just got the blank nut without the hole or thread. Next, I'm going to select the top face of the nut as a starting surface and click on the hole tool. Now I'm in the hole tool, I need to give it a position for the hole, so I'll just pick the origin. So we're going to have the new hole centered. And then we can go through and set the depth condition, so we want this to run all the way through the nut, so I'm going to change that to through all. And then under threads, I'm going to change it to from none to ISO coarse. Then that brings us the thread options, and in this case I'm just going to type and click the drop down and set it to M8. Now the final detail we need is, if we want this to be a fully modeled thread, we will check the modeled option here and then click OK, and that has now added the threaded hole to the nut. Now the other thing I need is a chamfer lead in and lead out at the other end. Now on the hole tool I could have used a countersunk hole to achieve this, but that would only allow me to have a lead in on one side of the hole. So instead I'm going to manually revolve a cut to create lead in one side, and then I can mirror that so I can have a lead in both sides of the nut. So to do this, I'm just going to select the XZ plane here and then click to activate sketch. And then I'm just going to draw a little diagonal line sort of cutting across the inside of the hole from the top. So if I just draw that triangle there, just using the line tool, I'm going to click the reset view. Now standard isometric threads are 60 degrees, so for this cut I want half of the thread angle, so I'm going to select that edge, and then I can just pick the axis here and define that as 30, so that should be the same matching angle to the thread. I'm going to start this revolve cut 3mm in from the center, and then I just need to specify the height. So for cut operations, it's usually a good idea to have your profiles a bit bigger than the part, so I'm just going to make 0.5 mm bigger, and then so the thread pitch is 1.25 mm for M8, so I need the depth of this to be a little bit more than half of that. So if I just select this top edge and then the bottom point of our cut and make that 0.7, that should now be a fully defined sketch, and that should be deep enough to create a full lead in. Now if we just go and rotate into a 3D view, we can sort of see that triangle is just intersecting the edge of the threaded hole. So I'm now going to click the deactivate sketch button top left, and under the cut remove material section with the sketch selected, I'm just going to click revolve. That brings up the revolve cut option. We want to go all round, so 360 degrees is fine. We just need to go dead axis, so click in the axis box, and then I can pick the Z axis here that's running through the center of the hole, and then click OK. And you can see that adds a nice clean lead in that marries up nicely with the M8 thread. And as mentioned, I'd like this on the other side as well, so I now select the revolve cut in the tree on the left. Under part tools, I'm going to go to mirror, and then under mirror plane, I was clicking the mirror plane box, and then I'm going to pick the XY plane here that's running through the center of the part, and then click OK. And that's now given us a lead in both sides. And with that done, I'm now going to go File, Save As, and call this M8 Hex Nut threaded. Now, just a word of advice on fully modelled threads. They are quite geometrically complicated. So depending on what your requirements are for the part, if you were using this nut just as to represent, off-the-shelf standard nut in an assembly, so you mainly need to understand quantities and locations, then I would just use the unthreaded nut we previously modelled. The reason to use the hole tool to create a fully modelled thread is if you want to use a manufacturing process where you're going to make the part directly from the 3D file, so output this as a step file or an STL and then send it to a 3D printer, for example, then in that circumstance it's an advantage to have the thread modelled. But if you're just using it sort of as an assembly feature, then I'd suggest just using a simplified version for performance sake, because when you add a large quantity of fully modelled threads, you're going to start making your assemblies quite heavy, and software's going to slow down. So anyway, I hope you found that useful, and now I'm finished with that. I can just click the cross top right to close and go back to the Alibre Atom 3D home window.